Hey there, honors algebra students. Mr. Lawrence here, and this is a first. I'm actually recording this from a hospital room. Things should be okay. My heart was acting a little bit funny, so I'm in the hospital. They're just checking me out. I'm hoping to be back Tuesday. There won't be any algebra, or excuse me, not algebra party. There won't be any math counts Monday. So if you're one of my four guys who shows up math counts regularly, we won't be doing it this Monday. But I look forward to seeing all of you Tuesday. So here's what's going to happen. You're going to get your lesson by watching this video. You need to pause it, take notes, etc. You probably want to work individually on this, though I wouldn't be against if you were behaving if you talked to the substitute and said, hey, I would like to listen to this with a friend. We're going to take notes together, etc. But please make sure you're staying on task. No horseplay, silly business, anything like that. Okay, so let's get on with the lesson. Today we're talking about unions and intersections. And the first thing you need to know is the definition of a union. And a union uses this symbol right here. It looks like a small u. Okay? The union of two or more sets is the set that contains all of the elements of those sets without repetition. Some of you are like, what? It's real easy. What it's saying is that if you have two sets, the union of those sets lists out all the members, but no more than once. Okay? If I was going to do the union of my first period class with my seventh period class, I would simply list all the names of my students. Yeah, that's all a union is. It shows all the kids, all the elements that are in the sets that we're talking about. So let's take a look at an example here. It says let u be the integers greater than 0 or less than equal to 20. Okay, so that's going to be our universal set. Now notice how that u is italicized. That doesn't mean union. That means the universal set. Okay, and so there I listed out the universal set. 1, 2, 3, 4, 5, 6. That's the entire set, right? Okay, let A be the set of positive even numbers less than 20. Okay, so I wrote A is equal to this set. And here I wrote the positive even numbers less than 20. I did not include 20 because it says less than 20. And then I'm going to name set B to be the set of prime numbers less than 20. And then I wrote that set out. So we have 2, 3, 5, 7, 11, 13, 17, 19. Okay? Now I drew a Venn diagram so we can get a better visual here. Okay? So let me get this whole Venn diagram down so you can see. You pause it. You can take notes on this, or you can go back and refer to the video. That's okay too. All right? Let me get a highlighter out. So we have set A, which contains all these numbers here. This is all of A. Let me see if I can color this right. It's kind of hard to color using the airliner. I don't know if I can color better with my mouse. Let me try that. It's similar. I guess I can't make it too much bigger, but there we go. This is all A, right? Except for that little part that's out there. Okay, now you're not going to hold me to my coloring skills. It would look so much better in class. Okay, there's A, right? We include all those members. Now, let me get rid of that and that right there. Now, I don't know if you noticed, 1 didn't appear in A or B. 1's not an even number, less than 20, and it's also not a prime. And so 1 is in the universal set, but it's not in A or B. It's outside A and B. Same with 20, 9, and 15, right? Okay, now, this is kind of cool here. Well, I'm going to come back to highlighting in a minute here. Okay, not just yet. In a minute. So let's see here. We want to find the union of A and B. Well, the union of A and B will be all the members of A and B. So it looks like the union of A and B, it's going to let me type it is going to include 2, 3, 4, 5, 6, 7, 8, not 9, 10, 11, 12, 13, 14, not 15, 16, 17. Remember how to 18, and of course 19. Okay, so there is the union, because the union of A and B lists all the members of A and B. Now, we notice one of the members is in both circles, isn't it? It's in both set A and in set B, but I did not list him twice. Okay, so that's what a union is. Now, I'm going to go back to highlighting in a minute. We have to learn what an intersection is. Intersection, oh dear, because I hit enter, my symbol moved. Intersection has the upside down U symbol. All right, I'm going to go ahead and get rid of the shade here. My intersections have all moved. All right, the intersection is of two or more sets is the set of elements that is common to all of the sets. To be an intersection, it must show up in all the sets we're talking about. Now in this problem, we're talking about set A and B. And I colored A yellow. I'm going to go ahead and color B blue. And watch, oh, look at that, isn't that cool? What's happening? Well, the part that's getting highlighted twice, yellow and blue, that's the intersection. Yeah, it's common to both sets. Okay, so I tried to make that very visual for you. Now, do you notice there's only one member in that set, only one number? Again, don't hold me to the coloring aspect here. It's, I didn't do it perfectly, but you get the idea. So I'm going to come down here. The intersection of A and B is simply just the number 2. That's the only element that's common to both sets. Okay, so now we know what a union is, and we know what an intersection is. A union lists out all the elements of both sets without repeating them. The intersection lists out the elements that are common to both. So let's try some examples here. All right, here's the first example. It says in box number 1, there is a brush, marker, and pencil. In box number 2, there's a calculator, marker, ribbon, and brush. I need to find the union. I need to find the union of these two sets. So let's see here. The union is going to include everything that's in both sets. So I'm going to need a brush, right? And maybe I should mark that off here. Let's get a crayon. I don't use my crayons very often. So I'll mark off brush. Then down here, I'm also going to mark off brush because it's already been used, right? Okay, so I've got my brush. Come on, there we go. And now I need a marker. And does a marker show up in both? It sure does. So I'm going to mark off marker. And I'm going to mark off marker here, right? So marker is taken care of. Now I'm going to need my pencil. Gotta have my pencil. Can't have class without my pencil. All right, so there's my pencil. And I guess I should mark that off, right? Pencil. Oh, don't clone the pencil. I don't want to clone the pencil. Pencil, there you go. Goodbye, pencil. All right, a calculator. Come on, there we go. Calculator. And then finally, a ribbon. Ribbon. Okay. And of course, I should mark those off. So there is the union of the two sets. It lists out all the elements that are contained in the two sets. Okay. But it doesn't repeat. Brush showed up in both boxes. Well, I don't repeat it. I just list it once. Okay, so now coming on down here to the intersection. Let me put my intersection back in place. And when I do that, okay, let me find the intersection. Well, the intersection would be the thing that showed up in both. And I saw brush in both, and I saw marker in both. So the intersection would be brush and marker like so. And there you go. There's the intersection of the two boxes. All right, now some more symbols have moved, so let me put them where they go. Otherwise, you won't be able to read what's going on. I suppose I don't want to lock them in place. All right, so let's check this out here. X equals the set of X, where X is a whole number less than 15. So if I wanted to think about X in actual numbers, it's a whole number, so I could start with 0, and I go 1, 2, 3. I'm not going to write them all out. They're going to go all the way to 14, right? I'm going to stop at 14 because it told me to only include the whole numbers, right? Didn't say real numbers. And so there is the set of x. Now, y is an odd integer. That's an infinite set. I can't list all of those, okay? But I know that's going to be 1, 3, 5, 7, 9 on forever, but it's also include -1, -3, -5, etc. Okay? Now, z is a multiple of 4. So that's going to be 0, 4, 8, 12. Obviously include the negatives, -4, -8, -12, on forever in both directions. So I'm not going to list those out. All right, the intersection of x and z. So in other words, what do they have in common? Well, I don't know what that symbol is, but let me write it out here. We need a little brace action going on. There we go. There's my brace. All right, so x is going to be whole numbers less than 15, and z is a multiple of 4. Let me go through and find the multiples of 4. Let's see. 0 is a multiple of 4. 4, 8, 12, and that should be it. Yeah, aren't 0, 4, 8, and 12 inside of z, right? Because they're multiples of 4. They're actually a subset of z. And in x, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way up to 14. Don't say 15. Which numbers would get said twice? 0, 4, 8, and 12. There's your intersection. Excuse me. Now, what's the intersection of y and z? Well, z has to be a multiple of 4. Z has to be an odd integer. Hey, wait a minute. If it's a multiple of 4, could it be an odd integer? I don't think so. So this is actually the empty set. Yeah, this set would be completely empty. All right. One more example to look at, and then I'm going to wrap this video up, and you guys can go ahead and work on your homework. The homework will be Excel 3.8, I believe it is. Okay. It says, of the 125 students at a middle school, some have music on Tuesday, some have art on Tuesday, and some have both on Tuesday. 68 have music on Tuesday. So I know that this circle here, I'm making a Venn diagram, by the way. This circle right here has to be 68. Now, at 68 here, the whole circle has to be 68. And I know it also says that 33 have both classes. They have music and art. So I know 33 is going to go here. Well, how would I figure out how many kids go in this part of the circle? Well, if the whole thing has to be 68 and there's 33, won't I subtract? Won't I go 68 minus 33 and ending up with 35, excuse me, 35. There you go. All right. Right? Those two make 68, don't they? And see, I'm all in the music circle right here. If I'm here, I'm in the music circle. If I'm here in the music circle, here I'm in the music circle, here I'm in the music circle. All right. Now, the question is, how many students have art on Tuesday? Well, I know there's a total of 125 students. So if I add up this piece, and this piece, I have to get 125. Well, I know what these two pieces equal. 68, right? So I'm going to take 125 and I'm going to subtract 68 from it. And I believe I'm going to get 57. Right? Okay. So what does this piece mean here? These are the students that only have music on Tuesday. Only music on Tuesday. Okay. These are the students that have both music and art on Tuesday. These are the students that only have art on Tuesday. They don't have music on Tuesday. All right. Well, the question is, how many students have art on Tuesday? Well, that would be the total number of students that have art on Tuesday. And to me, that would be 57 plus 33 or 90. And there you go. All right, that's it for the video. I expect you to, have taken notes on it. You can rewatch it again if you need to, but you're certainly welcome to go ahead and start the homework. All right, hopefully I'll see you guys on Tuesday. Mr. Lawrence signing off. Have a good night, everybody.